Today we're going to be talking about inverse trigonometric functions, and before we jump into that, let's do some review on the topic of inverse functions. A function is a special type of relation or correspondence that takes or assigns each member or element of a set in its domain to exactly one member of another set called the range. A relation is a function if and only if no vertical line intersects its graph more than once. You might remember this as being called the vertical line test. A function with domain A is called one-to-one if no two elements of A have the same image. Another way of saying that is f of x sub 1 should not equal f of x sub 2 whenever x1 does not equal x2. A function is one-to-one if and only if no horizontal line intersects its graph more than once. Now, if we have a one-to-one function, then the inverse function of that one-to-one function, f, is defined as f inverse. Now, I just quickly want to denote this. Because f is function notation, I just want to make sure that it's clear that this -1 does not represent an exponent. And so another thing to be sure of is f inverse, this notation, does not mean 1 over f. So make sure that you understand that. So f inverse is equal to the set of y, or the coordinates y sub x, such that x sub y belongs to f. In other words, f inverse of y is equal to x if and only if f of x is equal to y. So f inverse is the rule that reverses the action of f, and hence the domain of f inverse is the range of f, and the range of f inverse is the domain of f. The graph of f and f inverse are symmetric with respect to the line y equals x. So let's talk about this property. F inverse is the inverse of the function f if and only if f inverse of f of x is equal to x for all x in the domain of f, and f of f inverse of x is equal to x for all x in the domain of f inverse. We will see that in practice a little bit later. For now, we want to note that none of these trig functions are one-to-one. They are periodic and do not pass the they do not pass the horizontal line test. To be able to talk about inverse trig functions, we must restrict their domains. Let's see what that looks like in just a bit. So notice if I were to draw a horizontal line on our sine graph here, if I went like that, notice that it would intersect the graph at 4 different locations. And so our sine function does not pass the horizontal line test. And as it stands, we cannot create an inverse function because it's not one-to-one. So the way that we work around that is, if you look here, if we were to restrict our domain from negative pi over 2 to positive pi over 2, and we ignore the rest of the graph. So I'm going to cross all of this stuff out. And if we just focused from negative pi over 2 to positive pi over 2, now notice that that passes the horizontal line test and is in fact one-to-one. So that's what we have graphed below, is this black dashed line here is supposed to represent y equals sine of x between negative pi over 2 and positive pi over 2. And then the way we get sine inverse is by reflecting the graph about the line y equals x, which I'm highlighting in black here. So these two are mirror images of each other over the line y equals x. Knowing that the domain and range of a function and its inverse switch, and knowing that their graphs are symmetric with respect to the line y equals x, we can come up with the graph of y equals sine inverse of x. The inverse sine function is also called arcsine, denoted as y equals arcsine of x. Let's go ahead and define that inverse sine function. So the inverse sine function is the function sine inverse with domain -1 to +1 and range -π/2 to +π/2, defined by sine inverse of x is equal to y, implies that sine of y is equal to x. Note that some instructors and textbooks will call the inverse sine the arcsine and denote it as ARCSIN, like that for shorthand. So we have the following cancellation properties. Sine of sine inverse of x is equal to x for -1 is less than or equal to x, which is less than or equal to 1. And sine inverse of sine of x is equal to x when x is between -π/2 and +π/2. Those cancellation properties that we just talked about will come in handy when solving for angles within the functions, but also when looking at domain and range restrictions. Let's go ahead and jump into example 1, which says, evaluate the following expressions. Keep in mind that the range of sine inverse is between -π/2 and +π/2. Okay, so part A asks us to evaluate sine inverse of -√2 over 2. And so one thing quickly to keep in mind is that the thing that this is equal to is going to be an angle, because we're taking sine inverse of, this represents a length or a ratio of lengths, depending on if you're thinking about this in terms of a right triangle or being on the unit circle. But either way, the inside of the parentheses represents a ratio of lengths, and then sine inverse of that ratio is equal to an angle. So we are looking for an angle. And if you think about the unit circle, there are actually going to be, if we're thinking about between 0 and 2 pi, there are going to be two locations where the sine value is -√2 over 2. So one of those locations would be right here, where the y value is going to be -√2 over 2. And then if we reflect that over the y-axis, there's going to be another location where the x-coordinate, on this side of the y-axis, it should be -√2 over 2 for both the x and the y coordinate. And then on the opposite side, if we reflect over the y-axis, then it would be positive square root of 2 over 2, comma, negative square root of 2 over 2. And notice in both of the y coordinates of these points, the y coordinate is negative. So those two angles are this first angle, which would be well, the reference angle here is pi over 4, and then this is pi, so it would be pi plus pi over 4, which is equal to 4 pi over 4 plus pi over 4, which is equal to 5 pi over 4. And then the other location between 0 and 2 pi is here, which that would equal, because this, if we did a full rotation, that would be 2 pi, and the reference angle here is pi over 4. And so we would subtract pi over 4, and that would give us 7 pi over 4. But notice that neither of these angles are between -pi over 2 and pi over 2. And so neither of these angles are correct for our final answer. And if you look at the unit circle, if we go in the opposite direction, So if we go this way, then that reference angle was pi over 4. So going in the clockwise direction, that angle is going to be negative pi over 4. And negative pi over 4 does fall in this interval. So our final answer here is going to be negative pi over 4. All right, so part B wants us to find sine inverse of 0.75. And remember, what it is that we're exactly doing here is that we are trying to find the value. Another way of stating this is if this is equal to some angle theta, then we would have sine of theta is equal to 0.75. So we are looking for the angle such that when we take sine of it, it gives us 0.75. So another thing to notice here is that 0.75 is not one of those values that can be commonly found on our unit circle. So some sine values that we might think of on the unit circle is 1/2, 0, 1, root 3 over 2, and root 2 over 2. Those are, some of the common ones, and 0.75 is the same thing as 3 over 4, and that's just not one that you'll find on the unit circle. And so in order to figure out what angle theta we are looking for, we're going to need to use a calculator. A scientific calculator, in fact, or a graphing calculator, just one that has trigonometric functions on it. And so the first thing that I want to make sure is that I'm going to put my calculator in degrees because the answer is going to spit out an angle. And when we're in radians on our calculator, it usually doesn't put it in terms of pi. And so the angle that's given in degrees is just a little bit more intuitive to us. And so now what I'm going to do is I'm going to press second, the blue button, and then sine here. And notice the blue part says sine inverse. And then I'm going to type 0.75 and close my parentheses and then press enter. So remember, the thing that is being spit out right now is an angle in degrees, and it's 48.59. So sine inverse of 0.75 is equal to 48.59 degrees. And that should make sense. This is between negative pi over 2 and positive pi over 2, which if we put that in degrees is between negative 90 degrees and positive 90 degrees. So all of that is to say is that's another way of saying sine of 48.59 degrees is equal to 0.75. Okay, let's move on to part C. For part C, we want to take sine inverse of 6 over 5, and that is equal to some angle theta. And we could rewrite this in a different way, saying that sine of theta, whatever that angle is equal to 6 over 5. Now, we just got done with the section on graphing trigonometric functions, and if you remember what the graph of this thing looks like, it looks like this, where the amplitude is 1, and so the highest the sine value can be is positive 1, and the lowest the sine value can be is negative 1, and so this value is actually outside of the range of y equals sine of x. And so there actually is no angle theta such that sine of theta is equal to 6 over 5. And that means that sine inverse of 6 over 5 does not exist. Another thing that I would also point out is since 6 over 5 is not in the range of sine of x, 6 over 5 is not in the domain of y equals sine inverse of x, like that. Okay, so let's go through part D. We want to take sine inverse of sine of pi over 6. And remember from the cancellation policy earlier, we said that sine inverse of sine of x is equal to x for x values that are between negative pi over 2 and positive pi over 2. So basically these undo each other, and our final answer for this is pi over 6. Okay, so part E says we want to take the sine inverse of sine of 5 pi over 6. And this should ultimately give us an angle when we think about it. And so this thing here, we're taking sine inverse of a length or a ratio of length. So what's going to help us out is the unit circle. And the difference between part D and part E, the reason that we can't just cancel these out is because 5 pi over 6 was not between negative pi over 2 and pi over 2. And so that's why this example differs. But 5 pi over 6 is in quadrant 2, and our reference angle here would be pi over 6, and our terminal point there would be... Actually, I don't even need to know what the terminal point is for that, because if I reflect this over the y-axis, then this angle now is pi over 6. And notice that whatever the y value is here, it's going to have the same y value here. And so now I have found the angle that it falls between negative pi over 2 and positive pi over 2 that gives me whatever that sine value is. So we know that sine inverse of sine of 5 pi over 6 is pi over 6.